Hello, Tom Maratz here. I'm the project lead for the Residential Home Diagnostic Systems Project, RHDS. Welcome to our final presentation. We've put together for our final post, we've put together a video and we put together a blog post. In this video, we're going to cover off the goals of the project, and we're going to take you through our user interface. In the blog post itself, we're going to cover off all the technical aspects, and we're going to answer some of the questions that you folks were interested in finding out about. And we're also going to share in our blog some of the highlights that we experienced on our journey. Now, this project, it started out with a single thought, and that was imagine. Imagine being able to reduce your home's energy bill, increase comfort, and create a healthier environment for our planet. And that's something that we've had in mind for some time now in terms of building a product. But when the IoT challenge came along, it really motivated us to action. It was sort of like our call to action, so to speak, because you see, we've been watching the virtual IoT sessions now for quite some time, and we've been learning a lot, but we've never really actually applied that knowledge as to what we've learned, and that's all changed now because of this challenge and the project that we've built here. So before we go into the project, I want to take a moment and thank the Eclipse Foundation for all that they've done to put on this challenge. I want to thank the organizers behind the challenge and everybody that's really been involved, and the other participants too for their encouragement. And I think overall as a team, we're all working very hard here to make IoT more real to everyone. So onto our project. We're pleased to report that in our opinion, the project is an overall an absolute success. You see, what we've done here is it's something new. It's something that's never really been created that we're aware of, at least at the IoT level, where somebody's able to take sensors and measure heat loss in a home and then present that information. So we think this is a new thing, a one of a kind. And but why do we think that the project is a success? Well, we think that because of it's the way we've defined success. We had three big goals. The first one was, in fact, could we actually build an IoT solution? It's something we've never really done before. What we've created here, I think, is really a textbook IoT scenario. We just take sensor data, we move it up to the cloud, and then we present that information via user interface to the people that are interested in that information. We think it's a pure IoT solution, and we did it all in the time allotted. And it's actually a plug-and-play system. You can literally just fire up a sensor, brand new one, out of the box, and the data will flow up, and you can see it actually in the user idea here. And so that was really our first goal. Could we create a scalable, reliable, extendable IoT solution? And the answer is yes, and we're going to go through a bit more on the technical stuff and on our user interface to show you that. The second goal was really important, which was, can we actually measure heat loss of a building envelope using sensors with no human intervention? And the answer is yes, we can. We took basic building science physics formulas, and we were able to produce heat loss data. So the answer is yes, you can do this. And again, as we go through the user interface, you'll see what I'm talking about. The third goal also was really important, is that how do we know that the information that the system is producing is actually valid? So what we did here is we did an actual energy audit. So you'll see that in our third blog post, and where we take you through an energy audit. But in that energy audit, it produces some data, and we use that data as a baseline to measure our system against. So did the data line up? And the answer is yes, and it lined up amazingly well. And again, we'll show you that in a minute. So let's have a look at the RHDS system. And let's go through the user interface. Okay, this is our user interface. It's based on a real-time dashboard, and it's an open source project called Freeboard. Using Freeboard, we have divided the user interface into various quadrants. On the left, we have the status of the sensors and the components. It's a red light, green light type indicators, and it's handy for troubleshooting. What we're really after is the temperature data. We're after the external conditions and the internal conditions of a home. For external, we pull directly from the the weather from Environmental Canada Weather Service, and then for the internal, we use TI sensor tags. We use the temperature data to calculate the heat loss. If you were looking at our REST interface, you would see this data here all live. On the left is a graph, and this is actually a plot of the data from the energy audit report, and it's really what we were attempting to emulate. If our system could figure out that this line here, then everything else that you see in our system can be calculated. And of course we did that. So what you are really looking at here is 3 lines, but only 2 are visible. That's because our plot is directly on top of the energy audit results, and that was pretty exciting when we saw the numbers for the first time. The 3rd line here is what we call our textbook number. It's a plot of just what the plot would look like if you're just using basic heat load calculations without any kind of compensation, which we applied. And you can see it's still close, so the basic math still works for calculating heat loss. So once we had the basic formula down, we calculated everything else in terms of heat loss. So heat loss is shown in kilowatts per hour and in BTUs. And it's as per the EA report, that's what you'd expect to see. And we also calculate the air infiltration rate, which is the ACH, per hour. And as you can see, we calculated for ourselves about 1.93, and the actual number that the audit produced was 1.68. So those 2 numbers are actually pretty close. In a typical home, it's usually 3 or less, or in older homes, it can be anywhere from 5 to 10. So once we had our heat load calculation, we had the basic math, we could calculate this number, which is pretty exciting, which is basically the carbon output of the home against heating and cooling. And so we were able to come up with both hourly and yearly estimates for how much carbon is produced by the heating and the cooling. So essentially now a homeowner can see the impact from energy use. We're also able to assess the heating and cooling cycles for the home in real time and plot these. So a homeowner can, as in our case, the homeowner can see how long the furnace is on for and how long the furnace is off for. And of course, the longer the better. This is where energy efficiency measures come in. The homeowner should be able to detect the effects of improvements by seeing the cooling period lengthen per cycle. Okay, we also did some value-added stuff. Here you can see the average humidity across my house. I'm in the red here, so typically a home should be operating between 40 to 60%, so I'm a little outside that zone, so I need to do some work. We also have a view of zoning in the house. A homeowner can see the various temperature set points across his home, and then he can determine where the cold spots are and where the warm spots are and adjust the heating accordingly. And over here we have a temperature variation chart, which basically is an indicator of the high and the low temperature in the home. So if it's an indicator of how well your thermostat is performing, typically you shouldn't have much more than a 1 degree temperature swing. So again, the homeowner can see this and make adjustments accordingly. So that concludes our demo, and I hope you found that informative. You can certainly check out our live system if you like at the URL in the post. Okay, well that was our user interface. I hope you found that informative. So where do we go from here? Kind of what are our next steps? We know now that we can actually build an IoT solution, and in our blog we'll talk about the cost. We think we can do it as a do-it-yourself scenario for under $200, and we also know now that we can actually measure building heat loss through the building envelope. And so with those 2 things in mind, where do we want to go? Well, we want to, as a next step, we want to add more analytics to the system, basically more in-depth analysis. We want to add historical reporting so people can look at their activity over time. We'd like to improve the UI with a different interface that has more menuing and choice on it. And we're thinking about adding more sensors as well. We're thinking about looking at water quality. We're looking at air quality and also electrical energy use. And in terms of moving the project forward as well, we're looking at socializing the project now. And we're talking to various levels of government, and we're talking to various HVAC companies as well. And that's going well. And so what did we learn from this project? We go through a number of different things in our blogs, But basically, I think for us, it's that don't ever let anybody tell you you can't do something. You know, look what we were able to do with just by using the information that you folks provided, the open source and the tech. Just 3 people were able to put this project together. One of them isn't even a coder. That left the 2 of us, and one of those 2 people is a student who's in the middle of his midterms right now. So you can see good things can happen quickly with small teams here because of IoT and open source and open technology. In terms of use cases, we see applications for smart city, smart grid, smart energy, lots of smart applications, and they're all listed in our blog. But overall, I think what we're trying to do here and the value is that people will be able to see the impact of their lifestyle choices that they're making in their own homes, and I think that's the big one. In terms of this project, we think it's all about change. You know, we want to change how people look at temperature. We want to help them to see the connection to impact. We want to put the tools in the hands of people that can do good, you know, the experts, by exposing this energy use information, you know, out in the cloud where people can look at it and input. We want to make energy efficiency visible and factual. We want to move away from being an opinionated thing or subjective. We want to be able to create a better customer experience for HVAC companies, because now they can actually peer into the energy use of their customer's home and provide input. We're actually trying to promote the use of experts here. We're not trying to put any energy auditors out of business. No, in fact, we want the data that the system produces accessible to these experts so that they can look at it. We want to be able to help people see the fruits of their energy improvements, you know, with real numbers. And overall, I think we want to help people discover the balance between comfort and the climate impact by being able to actually see the carbon output that their home produces. So our project here is really just the beginning. We really want to build on this now. Climate change is real, and if you haven't been asked to do your part already, you will be soon. It's coming, and we need tools. We need IoT tools like the system here to help us in this endeavor to reduce the impact of what we do on the climate. So look, please visit our blog for more information and support us in our initiative here to help make energy use more visible to those that can make a difference. And remember, the changes that we make at home today will have a global impact on the world tomorrow. Thank you for watching.
Cheers!